In this video, we will be looking at examples from 1.6, and specifically we'll be looking at numbers 6 through 10. This is from our XYZ homework. Okay. These aren't exactly the same as the problems that you're looking at, but they are similar. So this one will be like number 6. Problem like number 6. Number 6 states, or a problem like number 6 will have the cube root of 40 x to the 4th power y to the 7th power. Alright, so in order to take the cube root of this, what we will first do is consider what are the perfect cubes of 40. Well, I'm coming over here to my scratch paper and thinking, what are the cube root, what are the perfect cubes? That is 1 cubed, that's 1 times 1 times 1, that's 1. 2 cubed is 8, 2 times 2 times 2. 3 cubed is 27. 4 cubed is 64. 4 times 4 times 4. 5 cubed is 125. Cubed, I mean to say. 6 cubed is 216. 7 cubed, I believe, is 343. Alright, so what 40. Which of these perfect cubes over here will go into 40? Well, 8 will. So I'm going to change 40 into 8 times 5. So now I'm taking the cube root of 8 times 5, and then I still have this x to the 4th and y to the 7th. Well, the cube root of 8 is 2. The 2 can come out of my radical sign. So now I have, the cube root of 8 is 2. It comes out. I have 2 cube root. The 5 remains underneath the radical sign. X to the 4th, y to the 7th. Okay. Well, now what do we do with this x to the 4th, y to the 7th? Well, again, we want to think about what can we take the cube root of. Well, x cubed I could easily take the cube root of. The cube root of x cubed is x. With y to the 7th, I could easily take the cube root of y to the 6th. It's y squared. So I'm going to now rewrite these two. Still have my 2 on the outside. We're still talking about the cube root. 5 remains. I'm changing x to the 4th to x cubed times x. I don't need to write a 1 there, but that's what we're dealing with. And y to the 7th becomes y to the 6th times y. Okay, again, y to the 4th became y to the 3rd times y to the 1st, and y to the 7th became y to the 6th times y. Why? Because now I can take the cube root of x cubed. Much like I could take the cube root of 8, and it was 2, the cube root of x cubed is x, so now that can come out. So, 2, still on the outside. The cube root of x cubed is x, that'll come out. The cube root of y to the 6th is y squared, because y squared times y squared times y squared is y to the 6th. Still have our 3rd root. So we took care of the y3 and the y6. What remains? 5, x, and y. 5xy remain under our radicand. Let me see if I can tell you how you can rapidly get from this statement to this final statement. I'm going to treat this much like it's a divisor. Here I have x to the 4th power. Consider, how many times will 3 go into 4? Well, it'll go in 1 time. So essentially I take that 1 power out with 1 left over, 1x remaining. How many times will 3 go into 7? 2 times. So here I have this y squared 2 times 3 is 6. We have 1 power of y left over. So if you can essentially divide each one of these exponents by this number, the whole amount will come out of the radical symbol and the remainder will be left over inside. That is a problem like number 6. Now we can look at one like number 7. Like number 7. In this case, we're looking at the square root of, say, 1 over 2. Okay? Back to our scratch paper, one thing we need to know is that if we have the square root of some fraction, like a over b, that is equal to the square root of both the top and the bottom, the square root of a over the square root of b. So we can take the square root of both. Well, so the square root of 1/2 is equal to the square root of 1 over the square root of 2. And we know what the square root of 1 is, it's 1. So what I have is 1 over the square root of 2. Well, the problem is this square root in the bottom. The math rules state that we cannot leave a square root in the bottom. It's just a matter of form. And that's very important for us on our XYZ homework. We have to have the right form. So we have to deal with this. We have to do a process that's called rationalizing the denominator. Rationalize the denominator. Okay. Back to our scratch paper. We know that 1/2 is equal to 3 over 6. They're the same, they just look different. How can we get from 1/2 to 3 over 6? Well, we can multiply. We can multiply by 3 over 3. Okay, 1 times 3 is 3, 2 times 3 is 6. This multiplying by 3 over 3 didn't change the value because 3 divided by 3 is equal to 1. And anything times 1 is that anything. So we went from 1/2 to 3/6. We simply changed the way the fraction looked. We didn't change the value. We didn't change the value because we multiplied by 1. Well, we're going to do a same situation here. I want to eliminate this square root of 2. I'm going to choose to multiply by the square root of 2. Because, to our scratch paper, any square root times itself simply comes out of the radicand. That makes perfect sense. If I said square root of 3 times the square root of 3, that is going to be the square root of 9. And clearly the square root of 9 is 3. So a square root times itself comes out. A square root times itself comes out. Thus, when I take the square root of 2 times the square root of 2, I will be left with 2. Well, I can't just multiply by this square root of 2. Whatever I do in the bottom, I have to do in the top. This factor here is equal to 1. Alright, so 1 times the square root of 2, that's the square root of 2. So what we see is we have this square root of 2 over 2. This square root of 2 over 2 is equivalent to 1 over the square root of 2, which is equivalent to the square root of 1/2. All of these values are equal. Okay, rationalizing the denominator. It means eliminating the square root from the denominator. We can have it in the numerator, we can't have it in the denominator. It's totally a matter of form. Alright, now let's look at one like number 8. Okay. In number 8, we have something like the square root of 20 minus the square root of 80 plus the square root of 45. Okay. We want to be able to add and subtract these quantities. It's much like combining like terms. If we have 2x plus 3y minus 5x, we know we can combine this 2x and negative 5x because they're like terms. 2x minus 5x is a negative 3x. The 3y, it stays. We can't combine it because it had a y variable while these other two had an x. Remember, like terms, same variable, same power. Same thing here. If the radicand, the number underneath the radical, is the same, then we can combine them. We call them similar radical expressions. So right now we cannot combine any of these because these numbers are different, but we can get them to be the same. I want to think about what are the perfect squares that will go into 20. Well, 4 will. 20 is 4 times 5. What perfect square will divide into 80? 16. 80 is 16 times 5. What perfect square we're going to 45? 45 is 9 times 5. Now we can take the square roots of these values that are perfect squares. The square root of 4 is 2. So this expression becomes 2 square roots of 5. The square root of 16 is 4. The 4 will come out. The 5 will stay in. Square root of 9 is 3. Now we can add or subtract these similar radicals. They have the same radicand, this number underneath, so we can combine them. 2 minus 4 is a negative 2, plus 3 is a positive 1. So this is 1 square roots of 5. We don't need that 1. I can simply write square root of 5. All right. Now let's look at one like number 9. Number 9 will have a multiplying binomials. Okay, let's say we have the square root of 3 plus the square root of 5, and we're multiplying that by the square root of 3 minus the square root of 5. Well, remember how we multiply binomials. We will take this first term, square root of 3, and multiply it by both terms in this second parentheses, the distributive property. Square root of 3 times square root of 3 is 3. As we said previously, a square root times itself just comes out. I'm going to show an additional step. Square root of 3 times square root of 3 is square root of 9. Okay, we know it's going to be 3, but I want to keep straight what's going on here. Square root of 3 times the square root of 5 minus square root of 5 will be minus the square root of 15. Okay, now we will distribute our square root of 5. Square root of 5 times square root of 3 in this case is plus square root of 15. And then lastly, the square root of 5 times the square root of 5 will be the square root of 25. Well, hopefully you see these two middle terms, minus square root of 15 and plus square root of 15, they will add to 0. We're left with the square root of 9, which we said is 3. And the square root of 25, which is 5. It's a minus 5. Alright, and lastly, 3 minus 5 is a negative 2. Okay. One last problem. Like number 10. Number 10 will have something to this effect. 2 over the square root of m minus the square root of n. Well, again, our problem is we need to eliminate this square root in the bottom. But here we have two terms. When we have two terms, we're going to multiply by what's called the conjugate. Okay? The conjugate. And what the conjugate is going to be is a binomial that will allow us to capitalize on difference of two squares. If we have square root of a minus the square root of b, the conjugate will be the square root of a plus the square root of b. Why? Well, you may remember from our difference of two squares, our factoring lecture, when I have a squared minus b squared, that factors into a plus b, a minus b. Because a times a is a squared and b times minus b is negative b squared. Well, the middle term cancels. Positive ab and negative ab cancels, so we just have this term. Likewise, we can do the same thing with our square root. If I have a minus b, it can factor into the square root of a plus the square root of b times the square root of a minus the square root of b. Again, we notice the square root of a times the square root of a is a. The square root of b times minus the square root of b is minus b. And the inside two, positive square root of ab, negative square root of ab will cancel out. So essentially what we're doing is going in this direction. If I have this subtraction, I'm going to multiply by the addition, square root of m plus the square root of n. Whatever I multiply in the bottom, I have to multiply in the top. All right. Well, what will square root of m minus square root of m plus multiplied by? Well, here we can see it. Square root of a plus square root of b times square root of a minus square root of b is going to equal a minus b. So my denominator in this case simply becomes m minus n. It's this form right here. Square root of a plus square root of b times square root of a minus square root of b is a minus b. You can distribute it and verify that. In the top, I'll have 2 times all of this. We could write it as 2 using parentheses, but I believe that you are going to need to distribute it for xyz. 2 square root of m plus 2 square root of n over m minus n. All right, and that will be your final answer. And that concludes this video.